Hey everybody, and welcome back to WySLICE. So by now you have developed an algorithm and you have applied it, and you've probably gone through a couple of iterations where you ran your algorithm and you found that something didn't quite work or didn't quite work as expected, and then you went back and you changed your algorithm and you applied it again, and then you saw that it worked, and maybe you did that a couple of times. So now we're going to do that in a more principled fashion. I want you to try and break your algorithm. That doesn't necessarily mean that you should only be playing the game and trying to find things where it doesn't quite work as expected, but you can actually think about the limitations of your algorithm. In what scenarios and in any maze that you have observed does it not work? Is it maybe completely broken, as in does it just not find the exit in these cases, or does it just take a much longer route than it should? Any of those are fair, but main point here is that this is kind of a more abstract exercise now, where you don't necessarily always play the game and observe what happens and then make inference based on that with respect to where your algorithm could be improved. But you really think about, well, in what cases would it break, whether these come up in reality or not. And the point of to make your algorithm more robust and more general. And that this is a fundamental part of computer science and of programming and of implementing an algorithm, because you cannot possibly test all scenarios, right? There's simply too many. Even if you have a very simple program that does some almost trivial stuff, there's usually so many different scenarios of things that could go wrong, external influences like the computer crashes. Okay, what happens then? When you restart it, do you get your work back? Has it been saved automatically? Is everything lost? These kinds of things. And not only can you not test all of these, in some cases it might be really difficult to do that, right? So for example, a computer crash. You can of course simulate this, but depending on how far you want to take this might be really expensive, as in you certainly wouldn't want to do this on your computer, right? And you just have it randomly crashing because it's testing a program. So this is really about building a mental model of what your program does and trying to figure out what the limitations of this are and where things might go wrong. So you can do this completely with pen and paper. Of course, feel free to go back to the maze and play it a little bit more and see if there's anything you notice there. But the main purpose of this exercise, as opposed to the previous one, where you applied your algorithm and through that observed when it worked and when it didn't work, is to really try to think about what your algorithm does and where the limitations are. So try to do that, and when you're finding these limitations and when you're finding the cases where your algorithm breaks, doesn't necessarily mean that you need to fix all of this, because in some cases, well, it might be really difficult or it might be even impossible. But the important thing is that you're aware of these limitations, so that if you were to implement this in code, if you were to write a program to solve the maze, then you would at least be able to alert the user to, oh, hang on, something is about to go wrong here. Maybe you want to watch out for that, or maybe you don't want to run my algorithm in this particular case. So not necessarily about fixing all of this, although of course that is very desirable. You want your algorithm to be general and you want it to be robust. So if you do realize that in a particular case it does not work, then try to come up with a way of fixing that. It's just that, as I said, in practice this can be really difficult, and in particular can make your algorithm much more complex. So you may not want to do this, but again, just be aware of where this happens, so that when you give your algorithm to somebody else, you can tell them, oh, actually in this particular case, watch out, it might break there, and yeah, fixing it would be really difficult. So just be aware of what's going on there. All right, have a go at that.